So in like 2 lines, we actually created Bedrock Agent Core because we were hearing from a lot of our customers that it is easy to build the POC when you are building using the agents. But when you are taking your agent from POC to production, there are a lot of pieces that comes in. Memory is one of those. So that is the primitive I'm going to talk about today. But there are other components like identity. How do you use that MCP servers? How do you use the other APIs to fetch the data? How do you make sure everything is secure? How do you observe all of the things that agent is doing to find where are the latency issues, where are the errors and things like that. And that is the reason that Bedrock Agent Core service came to life. But today I'm gonna focus on one primitive, which is Bedrock Agent Core memory. My name is Abhinav Sareen. I'm a principal solution architect at AWS. I'm based out of Vancouver. I drove in the morning like 3 hours to be here with you all. So thank you for listening. So here's the agenda. I have a full packed 25 minutes, so I'm gonna go through a little fast. And if you have questions, you can find me afterwards as well, or if we have time, we can take it towards the end as well. So first of all, why it's important to actually build context-aware AI agents? We discussed that. We discussed some of the challenges. If the customers are trying to solve these problems on their own, if they are trying to solve the memory issues and building those memory components, what kind of challenges do they face today? Then we'll talk about Amazon Bedrock Agent Core. What kind of memory do we support, and what are the concepts behind it? And we'll end up with an architecture as well. So what is needed to build context-aware AI agents, right? So today's world with a lot of reasoning models, and these models are so great now, they are thinking all the time, they are outputting all of those tokens. If you're building a multi-agent orchestration system, then you have hundreds or maybe even thousands of tools accessible to these agents. So their context is getting really large, right? And as the context is growing, it is difficult for the agent to find the right context. And if it doesn't have the right context, you won't get the accurate answers. So one of the ways that we solve that problem today is giving agents the memory. Now let's look at 2 scenarios. And it's very common. We see that every day in our life as well. Agents without memory. So let's say you are talking to a customer support agent, which does not have the memory. And you are asking a question, you get the answer. You came back a few seconds later saying that doesn't work. Can you give me something else? And the agent forget about the conversation that it had with you, right? And then you have to explain all of the things again. So it's very frustrating. And it happens even in the real life, like when we are talking to a person, which is human, and sometimes you explain all of the issue, and later on they say, hey, different department, let me transfer your call. And then you have to explain all of those things all over again. So that is the exactly problem that agent memory is trying to solve, where we give the memory to the agents, and everything that you're talking in terms of raw messages are getting stored. There are also a lot of logic around the semantic memory, which is getting stored as well. So the idea is the next time when you do the follow-up, it can actually pick up from where it left off with you in the conversation, and you don't have to explain all of this thing all together again. So we say that AI agent without the memory is like a goldfish. Everything is new every 3 seconds. Right, so here's a conversation, very simple one. And we have all seen that. Like in the last 2 years, we came from the LLMs where we were talking to the chat GPT and like other models where they were forgetting things, right? And now we know how much context they can have and how much memory they can retain. So in this particular case, it's very simple. We were talking to the agent, and once we asked the follow-up question, it already forgot that we have iPhone 16 that we explained just one chat above. Obviously, not very personalized experience. Its loss of context does mean the customer experience won't be great, and it won't be personalized as well. So we want to build the agents that are not just remember things, they are also smart. They can identify, they can find the contextual information, they can recognize the patterns, they remember your user preferences. So today, if you tell an agent, which you are talking to, let's say if it's a retail agent, maybe on Amazon.com side, and you tell like, I want to buy a headphone and I like Bose. So it should remember that you have a preference of Bose headphone or a Starbucks coffee. So next time when you go, you don't have to explain all of the things to the agent again. And then it also needs to retain some of those data. Now it cannot retain all of the raw messages, like all of the conversation that you're having with the agent, but it needs to retain the summary or semantic information so it can help you better when you come next time. Okay, so let's start with the agentic memory core concepts, and then we'll deep dive into the Amazon Bedrock memory concepts. So there are two types of memory. One is a short-term memory. We call it a raw memory, and also another one is a long-term memory, which is intelligent memory. So short-term, very, very similar to a RAM of a laptop, right? It remembers things for the short terms. And then long-term, we can think of as a hard disk, which is persisting the information like the user preferences and other semantic information and facts to help you. So what do we have in short-term memory in general? We have ongoing conversation context. So if you are talking to a customer support agent, chances are all of the raw conversation we want to store into a short-term memory so we can fetch it very quickly. Current session attributes, some checkpointing information. So if the session is left off in the middle and you came back again, it knows exactly where to start from. And in the long-term memory, we want to not store all of the raw messages because that would be too much, but we want to store some of the user preferences. Like I said, if you like a Starbucks coffee or a Bose headphone. Session summary. It does want to store, for example, you start a session with an agent and later on your conversation ended. So it won't store all of the raw messages in the long-term memory, but it will store the summary of that in the long-term memory so that next time when you come in, it can actually retrieve that memory and serve you better. It also learns facts and concepts. So if you're talking to a customer support agent and you're talking about a particular product that you bought, while it will retain the summary, it should also retain some of the facts, like what is the return window for this particular product? For how many days you can do a price match. And with all of that memory, when you do the retrievals, the agent behavior is customized based on what it learned from you. So here's an example of short-term memory. So in the same example that we were using before, now if the agent has the short-term memory, it does has all of the context into the short-term memory, and now it doesn't have to ask you again what kind of iPhone you're using. Okay, so how about long-term memory? So this is an example. I like Bose headphones. My company give me 25% discount, and I prefer white open ear headphones. And this is something probably you're talking to a retail chat agent. Now, in the short term, while the raw messages are there, in the long term, we do have these preferences. So now it is storing user preferences like Bose open ear headphones, like white color. These are the two things that will be storing in the long term. And whenever you come back again and ever you want to buy a new headphone, it already knows all of your preferences and it says, I'm happy to help. It'll give you some of the options about open ear Bose headphones. Also considering that you get 25% discount, this is what it's gonna cost you. And this memory gets updated over time. So if you change your preference tomorrow from Bose to something else, that will be updated in the memory as well. So there are three different strategies for long-term memory. One is semantic, where in this particular case, the user is saying, I need to return my Bose headphones I bought last week. These are great, but I got a cheaper one, which is $100 less. Now, in the semantic, we also have those facts, which we are storing. So here, let's assume for this particular example, we already have the facts extracted when the user was having the conversation and it's already stored in the long-term memory. So now the agent can come back and say, you already have the price match for 14 days. So if you want to do the price match, I can do the price match rather than you going and buying a new one. So this is exactly the personalized experience the customers are looking for when they are going to talking to the support agent or retail agents and different booking agents. Okay, what else does it do? So one is semantic memory that you're storing in the long term, which also includes the facts. It is also storing the summary. So once the session is ended, it stores something like this. User bought a new white open ear headphones as they wanted to change the old ones and found a cheaper one later, which is $100 less. So it's also storing kind of a summary once the session is ended. So next time if you come and say, I broke my headphones, it already have all of the information it is needed to either help you get some support or help you get a new one. Okay, so what are the challenges in building this? So if you want to build your own memory layer, where you want to build a short-term memory and long-term memory for an agent, there are some issues, or at least scalability-wise. So first of all, you need storage, right? You need a storage and probably a different storage for a short-term memory and for a long-term memory. So you want very, very fast access to the short-term memory, and it could take a little bit longer because you are persisting all of those records to the long-term memory. So different storage you need to manage for these memories. You need to refresh your memory, right? So if the agent is having the conversation and user change the preferences, you need to make sure that is consolidated, it's updated, fixed, and you don't have duplication of the memory as well. There are a lot of complexity around integration, privacy, and security. So if the agent is accessing the memory, how do you make sure the agent has the access to that particular memory that it is trying to access? So based on the agent ID, actor ID, session ID, there's a lot of complexity that you need to build in to make sure that it is using the right information or it is accessing the right data. Now there is also a retrieval accuracy problem. So that's another one. If you have a very, very long messages that are stored in long-term memory or even in short-term memory, and tomorrow you need to retrieve that, and with all of these agents, with kind of tools they use today, if you don't give the right context to them, then you won't get the accurate answers as well. So you need to find how, whether it's semantic memory or you are doing some graph-based search, you need to find out the right data to pass it to the agent or context to pass it to the agent. And finally, the observability piece, very, very important. You need to make sure that we can look at and see where exactly agent is spending time, if there is API errors, invocation issues, things like that. So a lot of things to take care if you're gonna build it on your own. And that is what we were hearing from the customers. And this is just one primitive. So if you are building an agent which you are taking from POC to production, this is just a memory piece, and you have to do so many things for the memory piece. But if you are also doing identity or accessing external data sources, then you need to build even more of these primitives on your own. And so that's part of the Bedrock. We have 6 different primitives that is provided to the customers out of the box. So it's a fully managed service. But as part of AgentCore memory, we do give core infrastructure. So you got serverless setup, very, very minimal configuration that you need to do. It has built-in encryption at rest in transit. You have flexible namespace for memory sharing. And namespace is the concept that comes in for the long-term memory. So it's very, very similar to the folder structure. So if you are storing something in the long-term memory, you can decide how do you want to store it, how do you want to efficiently fetch it as well. You can decide on the time to live. That is for the short-term memory. So we have 7 days to 365 days that you can choose to have the short-term memory events live in the short-term memory. And then you also have the observability piece. You can switch it on. So all of this fully managed. On the management layer, you have memory management. You have short-term, long-term memories, built-in memory consolidation. So I talked about one of the challenges that is there when you have additional memory or a different memory or additional pieces, you need to consolidate all of that as well because memory get outdated over time. So that piece is already built in as well. And we have one API to create short-term and long-term memory. So very, very simple. And finally, you also get delete and list APIs as well. On the extraction side, you can do memory extraction strategies. There are 3. Talked about it. Summary is one. You can do semantic. And there's one more. And you can also choose your custom strategy. So if none of those strategies works for you and you want to build your own strategy based on which you want to retrieve the memory records, you can do that as well. Yeah, user preference is the third one. And automatic memory extraction happens. So like when you are talking to an agent, all of the raw memories are events all getting stored in the short-term memory, but you don't have to do anything from short-term memory to extract to long-term memory. That is all taken care by Bedrock. So it will take the short-term memory and structure it and push it to long-term memory as well. And then you have filtering options. You have semantic and filtering when you're retrieving the memory back to the agent. Okay, so let's look at a high-level overview how it looks like. So you are talking to the agents. It goes to the raw messages, goes to the short-term memory with the sync. So it has to be stored in the short-term memory. Then it goes to the memory extraction module, where the records are structured, structured, we create the embeddings and index it and store it into a vector database in a long-term memory, basically. Okay, diving a little bit deeper on the short-term memory side. So here is the agent. It is talking and it generates the events. And events are like all of the messages that you are having with the agents, and also some of the JSON data. It could be images or document that you pass to the agent when you're talking to it, right? So all of that is part of the events, and then these events are getting stored in the short-term memory, raw messages that you can always fetch when you are initializing your agent. And then finally, if you want to do list those events, that's a sync operation back from the short-term memory. So three main core concepts that comes when you're talking about short-term memory is events, which is the record of interactions and conversation that you're having with the agent. Actors, that is how we identify who the memory belongs to. So it could be an agent or it could be a user. And finally, the session. The session is something that you are having the conversation with the agent. As soon as you end the session, that's what the session is. So session is the conversation. One session can have multiple events, and one actor can have multiple sessions. So as a user, you can open multiple sessions, and one session can have multiple events as well. How is the developer experience looks like? So this is how simple it is actually to create the memory. So here is an example with a simple API. You can give it a name and a description and TTL, and it will create the memory for you. This one, it's only creating the short-term memory right now because we have not given the strategy. Once you add the strategy into that, it will also create the long-term memory with the same API. Okay, so once the memory is created, you can create events. And this is how you create events. You give memory ID, actor ID, session ID. When you're building your agent, obviously it will automatically be fetched from the session when it is talking to the agent. And it also has the conversation. So if you can see here, we have user and assistant. So it does have that conversation along with the tools lookup calls as well. So these conversation will also be stored as part of the events into a short-term memory. And once a limit reached, like let's say 8 times these key events, then it will automatically be extracted to a long-term memory as well. But this is how you create event. These are the two very, very simple API calls to get the events. So if you want to, and in case of events, like a short-term memory, there is no memory retrieval, there is an event retrieval. So you can list the events or you can get the events. So if you want a particular event, you can get it. Or if you want all of the events that is there in the short-term memory, you can get it using the list events. Okay, so that was about the short-term memory concepts. In the long-term memory, I already talked about some of the strategies that we have. So we have summary, we have user preferences, we have semantic, right? So one thing to note, the semantic is also storing the facts. And finally, you have custom as well. So if none of these strategies work for you and you want to control how do you want to consolidate the memory, which model that you want to use to consolidate, whether it's Sonnet or Haiku, you can do all of that when you're using the custom strategy. So let me show you very quickly how it looks like. So here we have an example of creating a custom memory, custom strategy. So it's a part of long-term memory, and you give the strategy name, type, namespace, which is common for any of the strategy that you're creating. But in the extraction model, you can choose the model that you would like to extract that. You can give the prompt as well, and then for consolidation side as well. So in this case, it is using two different models, one for extraction, which is Sonnet, a larger model, and one for consolidation, which is Haiku, a smaller model. So full control over how do you want to extract and consolidate in case of custom strategies. Okay, so now let me quickly talk about what a namespace is. And that is how you store your memories in a long-term memory, right? So it's a logical group. It organizes the memories into a folder kind of structure. You can see that you can have that hierarchical structure with the hashes, just like with the slashes, just like the folder structure that we have. And it can also include variables. So in this case, we have actor ID, strategy ID, session ID. So it depends on your application, how you want to segregate that as part of the long-term memory. You can choose the right strategy as well. And this can help you retrieve the memory faster. So this is just one example from most granular, where you can see on the top, we have at the session ID level and also have the actor ID, and then very, very global as well. So depending on kind of application need that you have, you can choose one of these strategy as well. Okay, so how do we create the long-term memory? And talked about the same API that you use to create the short-term memory, you can also use to create the long-term memory. In this case, the only difference is once you provide the strategies, and here we are providing this session summary. So it's basically the summary strategy that we are asking it to create the long-term memory with. And we also providing the namespace, and that's how it creates the long-term memory. And one thing to note, when you create a long-term memory, it will automatically create the short-term memory. So short-term memory is already created because the long-term memory is only extraction records from the short-term memory. So it has to have that short-term memory for long-term memory to exist. So that's why same API you can use to create both of these. Okay, so how does this extraction looks like? So you have a short-term memory, which is a collection of kind of a raw events plus session data. Then you extract the event and the strategy. So if, for example, if you choose semantic or user preference or session, depending on that particular configuration, you can fetch events and the strategy from short-term memory, extract it, consolidate, then create the embedding and indexing, and then it will be passed on to the long-term memory, which will be stored in a vector database. And it is a sync operation. Obviously, we don't want to wait while it is happening. So once you have written the events into a short-term memory, that is what is a sync operation. And once after that is written, it will in the background will do a sync operation where it will take the events every k messages or every like 20 seconds, and it will push all of these, build a summary or semantic and push it to long-term memory. One more thing to notice, like before pushing, it will see that consolidation logic. So it will retrieve the memory from the vector database just to see if the memory already exists and whether it needs to update it or add a new one. Okay, so this is how it looks like with both long-term and short-term. I was just saying it's coming a little bit differently. It wasn't in the system. Okay, so agent is talking to the to a user, and it is generating the events, conversational plus JSON, right? The images and the documents. It goes through this sync process, and it will store all of these things into a short-term memory. Now from short-term memory, there is a sync process which goes through this memory extraction module, which will find the right strategy that you choose. You can also choose combination of these, whether it's user preference, semantic, or summary, and it will generate the long-term memory based on that. And once it is generated, you can either receive list events from the short-term memory. Remember, there is no memory extraction from short-term, it's only the events. Or you can retrieve the memory records from the long-term memory. And both of these are the sync operations. And how do we create? It's very, very simple. Same, create event. When you create event, it will create the short-term memory, and obviously it will also take all of these conversation that is happening every 10 conversation or 8 conversation, it will go and push that to long-term memory as well. And the retrieving memory is also very, very simple. You just use retrieve memory commands, give the ID, give the namespace, and then it will extract that long-term memory that you are trying to extract. Now observability is built in, so everything that you're doing with the agent and all of the memories, it's all stored into the CloudWatch. So you can go in and look at what kind of memory extraction happened, how much time it is taking, timestamp, all of the metadata, errors, invocations, all of that is available to you. Okay, we had time. Let me talk about 2 more architectures very quickly, show you how does it work in the memory wise. So this is an example of a short-term memory, right? So there's a user. Now the user is asking a question, and this is a strand agent. Have you worked on strand agent? Anybody tried strand agent before? No, so it's our open source SDK. Okay, so it's our open source SDK to build the agents. Really simple, and you can use any model in the world to build it with this one. So if you want to use Gemini or OpenAI models, you can do that along with the Bedrock models to use strand agents to build the agentic frameworks. So the user question goes to the strand agent, which is in the local environment right now. Now this strand agent is talking to Bedrock to get the model um, from Bedrock. So it's using that model. It also has access to tool. And then we can also hook it up to Bedrock AgentCore memory piece. So now how it build it, even though it is in the local environment, it build this memory in the AgentCore memory. And now it can store the conversation which is having in the events in this to short-term memory, and it can also retrieve that events from the short-term memory. So for example, if you build this kind of agent which has the short-term memory, all of these things are stored in Bedrock AgentCore memory piece. Now, next time when your agent initiates, you can automatically add the hook to extract all the like 5 events when the agent talked to this user in the past. So at least it has all the information it needs to actually start the conversation or pick up from where it left off. So this is how the short-term memory works. Long-term memory is very, very simple. The only 2 different pieces are you don't have to do anything. From short-term to long-term, it will automatically be extracted. And when you retrieve, you don't retrieve events, you retrieve memories directly from the long-term. Again, you can ask the agent when it initializes, it can also get that long-term memory into the agent as well. Similar, it is using the Bedrock model here. It can also use web search as well. And finally, if you are building an architecture, most times you will have both short-term and long-term memories, and this is how it looks like. So here we have a multi-agent orchestration architecture, where is the orchestration agent, which is a strand agent. Now it has access to 2 different agents. One is a flight booking, one is a hotel booking agent. And both of these agents can talk to the short-term memory, automatically come to long-term memory, and can retrieve events. And this can be done using the memory hooks, which are deterministic way to actually push those events back to the short-term memory. All right, so we are timed. So that's all I have. Thank you. I can take some questions. Yes.
The way that you structure the namespaces for the memories reminds me of composite index keys in DynamoDB. Does that mean, is Dynamo being used under the hood, like as the storage mechanism for the memories?
No. And Dynamo is not being used. The name structure, we want to give the flexibility to the users, because sometimes like how the ISV treat an agent would be a different from an end customer or a partner, right? A consulting partner. So we wanted to actually give that flexibility, whether you want to actually fetch the memories based on actor or based on agent or based on the directly end user. And that's why these namespaces are for. These are just the logical, you can think of it as like an S3 when you create the folders. It's very, very similar to that. Now, which databases are using under the hood, that information is totally abstracted away. So that is not shared with the end customers, like when you're storing the short-term memory or long-term memory where it is stored. But we can share some of the things like what kind of latency you can expect when you're retrieving the records from long-term versus the short-term.
You talked about the short-term memory to the long-term memory distillation. How does that happen? Like, is it dynamic, or does it happen on every query?
Yeah, it's automatic, and it happens like every 8 or so turns. So if you're having a conversation with the agent 8 times, when you and the agent are you are asking questions, agent is replying, so like after 8 turns it will automatically go ahead push it. It's all automatic under the hood. If you are not doing that, like if you don't even have the 8 turns, then it will automatically push it like every 20 seconds or so. But if you are using custom, then you can control it as well. We are using LLM, yeah. So the question is for short-term to long-term, are we using some kind of an agent to do that? We are using LLM to do that, not agent. But yeah, we are using LLM that converts and obviously find all of the pieces. Like it is a very long raw conversation. We want to make sure that it extracts the right details. So that's where the LLMs comes here. Yes.
The semantics between event and message, is event kind of like a batch of messages? That was the only part I didn't understand.
Yeah, so events is like a user question, assistant answer, and if there is any other tool calls. So all of these 3 combination, along with if you actually pass any document to it or image data where you're asking the question about the image. So that blob data along with these 3 conversation and plus some metadata and a session state. All of these is one event.
So it starts with
Yeah, that's one event. Yes.
So in your, like, can you go on the slide, like the last slide? One before. Yeah, yeah, the next one. Over there, like the long term and short term project. So over here you can see that only long term memories are getting like retrieved. Why not short term memories? Like
Yeah, so
it
this
might
is,
be the case like the user has like short term memory, it has like maybe it likes a pizza, but the long term memory is it doesn't like gluten. Uh,
yeah, and this is just a slide to show how the long-term memory works. So if you see the next one, and you're absolutely right. So when you're building like a proper agentic system, you will have both. So in this case, you can see both of these, and it doesn't have to be restricted to like the multi-agent orchestration architecture. So if you are building it like for a real production use case, this is just to simply show like, hey, before we showed like how the short-term memory works, you can retrieve the events, and in the long-term memory, retrieve the memories. But when you're building a real system, you'll have both of these. You'll retrieve the events along with the retrieving the
but
memories
don't
as
you
well.
see like conflicts in long term and short term? How do you manage that?
No, like you can retrieve k and k events from the last conversation. If the user is having the conversation and it doesn't find it in the short-term memory, then it can go to the long-term memory and do the semantic search or like retrieve the memories based on what information is missing. But if it finds everything in the short-term events, then it will go ahead and use that. All right. Thank you so much.